will sail through the air. It said its radiation using infrared. The sun provides the truth, the rays come down on you. Fireplace on inside, you feel the waves of fire. No matter how the heat, different temperatures meet. No matter where he's from, I'm too cold how it's done. Radiation heat, it goes through the skies, connection through its lines. It's where the heat supply. Don't get too close. You touch the fire. Connection heat goes by. Three ways heat is supplied. Out on the sand that's warm. When the light is out, all your toes get burned. So the heat in place will be passed away to the molecules of the nearby space. All this is conduction, works well in solids, though this heat will come through liquids, that is true. No matter how the heat, different temperatures meet. No matter where he's from, I'm too cold how it's done. Radiation heat, it goes through the skies, connection through its lines. It's where the heat supplies. Don't get too close. You touch the fire. Connection heat goes by. Three ways heat is supplied. They say when heat will make the fluids near it change. The liquids and gases make convection currents. The air it changes right from source of heat or light. It's moving to and fro, bringing heat with it now. Radiation heat, it goes through the skies, connection through its lines. It's where the heat supplies. Don't get too close. You touch the fire. Connection heat goes by. Three ways heat is supplied.
All right. So this song is an Imagine Dragons song originally. However, this song is called Radiation, Conduction, and Convection by Mr. Parr, the extraordinaire of all science songs. So if you like my science songs, you definitely want to check out his YouTube channel because he is the bomb.com. All right. So thank you to those of you who responded in the chat while the song was playing as we were reviewing some of the things that we learned about heat transfer, even introducing some new things about how 3 ways heat can be transferred. We're going to continue to talk more about that next week. But I was loving some of the things that I saw. And yes, Cullen, you should probably be really scared because you never know what to expect when it comes to science. So yes, knife can turn red from the heat because the heat's being transferred, I'm assuming, from the fire or stove or whatever super hot source it's coming from, heat source it's coming from. Let's see, it can go from a hot piece of glass to a cool spoon or object. Yes, heat transfers from hot to cold. Excellent. Molecules are spread apart. Excellent. A glass container, heat waves will go right through it. Okay. Excellent. Heat is anywhere. Yes. Only in super awesome, specially designed scientific laboratories have they been able to reach absolute zero, which means that there is no heat energy. The molecules are not moving at all. And the temperature is like redonkulously low, like negative hundreds of degrees, to reach absolute zero. So yes, everything that we know of has heat, even if it's cold. All right. No, Cullen, you gotta hang around. You got lots to learn. All right, so today we're gonna be talking about how if we place a warmer object close to a cooler object, or in the observation, we actually put the warm object inside of the cooler object, and we're going to measure the time and temperature changes of both objects and discuss the results. So before we get to that, let's review a little bit. Who can tell me what heat is? Raise your hand. Oh, just kidding. What is heat? I'm looking for my participants tab so I can see who's raising their hands. I know who to call. Nobody? What? What's heat, guys? We've been talking about it. It is the star of the show today. What is heat? What do we know about it? I'm going to start calling on people I have not heard from today. Harlem, what is heat?
Heat is a whole bunch of moving molecules, and they keep moving.
Okay, excellent. So you're right on track. So heat is a form of energy, and it is caused by molecules moving in matter or any type of object or space. Yes, definitely. Perfecto. So what is temperature? Because you guys have done an assignment on this. You were to explain the difference between heat and temperature. So what is temperature? What is temperature? Somebody raising their hand? No? All right, guys. Well, I'm going to have to advance on to the next slide because I'm not seeing any responses and we are running out of time. Our time is limited together. So heat is a form of energy. And just like Harlem said, it comes from the movement of molecules in matter. Now, the temperature of objects is very specific. It tells us the exact amount of movement that the molecules have. So something at 68 degrees has more movement than maybe a piece of matter at 32 degrees. Now, which most often occurs when a pot of water boils? Is it condensation, freezing, melting, or evaporation? What happens when a pot of water is boiling? Yes, Leyland.
It evaporates.
It evaporates. Yes, Cullen. What were you going to say?
Same.
Okay, so how do you know that evaporation is happening?
How you know it happens is because you start to see less water and more steam.
Yes, yes. So steam is our proof that evaporation is happening, that the water in the pot is turning to a gas and evaporating into the air around us. So yes, and then you went a step further. You said the water will be decreasing and the steam is increasing. Yes. Now, which best describes the flow of heat? We only said this about 1,000 times in the song that we just listened to. Which best describes the flow of heat? Is it from a larger object to a smaller object? I would appreciate it if my friends would not be annotating on the screen because I have not asked you to. Is it from a warmer object to a cooler object or from a cooler object to a warmer object? How is heat transfer done? In the song it says, dun dun dun, how it's done. Radiation heat, it goes through the sky. But before it gets to that, it says, dun dun dun, how it's done. So how does heat transfer flow? Kind of rhymes with that Go Noodle song. Popsicle, pop, popsicle. Hands are high, feet are low, and this is how we popsicle. Well, we have a heat transfer rendition that goes with that. It says hot, too cold, hot, hot, too cold, hot, too cold, hot, hot, too cold. So heat transfers from hot to cold. So which of these best represents what we know about heat transfer? Josiah.
Heat transfer is Heat transfer is kind of like, it's like what you said, put on one of our questions.
You're answering the question that's on the screen here. Which best describes the flow of heat?
Oh.
Is it from a larger object to a smaller one, from a warmer object to a cooler one, or from a cooler object to a warmer one?
I would say C. Hold up. I don't have my glasses.
Okay. Emmett, he doesn't have his glasses. Can you help him out? What best describes the flow of heat?
What best describes the flow of heat is I'm gonna say a from a warmer object.
Yes, excellent. So a synonym for hot would be warm. They kind of mean the same thing. Cooler object is the same as cold. So if we know that heat transfers from hot to cold, then of course the best answer here, Emmett, would be from a warmer object to a cooler object. Excellent job. Fantastic. All right. Now, this is what you needed to complete your assignment, especially that second question where it talks about what's happening between 40 and 60 seconds. So, it says that heat is energy transfer between substances or systems due to a temperature difference between them. The greater the heat difference, the faster heat transfer occurs. So, in the video, you guys observed heat transfer taking place between two containers of water, the warm water that was put inside of the cup of cold water. So for that second question, what happens between 40 and 60 seconds, it's very important to remember that for heat transfer to take place, there has to be a difference in temperature between two molecules or matter or two objects. And when there is a greater difference in temperature, so when one is much warmer or much cooler than the other, then heat transfer is going to happen much quicker. Kind of like dropping a ice cube on a hot stove. It's going to start melting immediately versus dropping the ice cube like on your table. There's not as much heat in your table as that's on the stove. Thank you guys for responding in the chat as well to the multiple choice question. I appreciate that. I just saw that. All right. So that is all I have for you. I'm hoping that by this point you guys have watched the video. And if you have any questions, please ask them now or forever hold your peace until tomorrow at science time. Anybody? Anybody? Going once.